Hello, everyone. My name is Rebecca Parsons. I'm the Chief Technology Officer Emerita for Thoughtworks, and I'm joined today with three guests to talk about the topic of AI refactoring. And first, I'd like to introduce Adam, who is the founder of CodeScene. Adam, please say hello to everybody.
Hello, everybody. Really good to be here.
And Birgitta, a principal technologist with Thoughtworks, who is leading our efforts in AI-assisted software delivery. Birgitta.
Hi, everybody.
And Martin Fowler, our chief scientist, author of the book Refactoring. And we are here to discuss AI refactoring in all its glory. One of the things that had disturbed me very early in many of the studies that were done on the power of tools like GitHub Copilot was they focused on speed and they focused on task completion. And no one ever said anything about code quality, and nobody ever said anything about, and oh, by the way, how is this going to help us with all of the legacy code that we have? And so that's the topic that we are going to discuss today. And so let's start with the question, how do we characterize code quality? What does it mean for code to be good code or bad code?
The interesting thing with code quality is that there's not a single metric that can capture a multifaceted concept like that. I mean, no matter what metric you come up with, there's always a way around it, or there's always a counter case. So what we've been working on for like the past 6 to 7 years is to develop the code health metric. And the idea with code health is that instead of looking at a single metric, you look at a bunch of metrics that kind of complement each other. So what we did was that we looked at 25 metrics that we know from research that they correlate with an increased challenge in understanding the code. The code becomes harder to understand. So what we do is basically we take these metrics, there are like 25 of them, stick them as probes into the code and pull them out and see what did we find. And then you can always, weight these different metrics together and you can categorize code as being either healthy or unhealthy. But my experience is definitely that when code is unhealthy, when it's of poor quality, it's never a single thing. It's always a combination of factors.
Yeah, it's interesting what you said that. So the metrics that you chose, like one of the main factors you use to choose these metrics is, do they improve readability, yeah?
Yeah, definitely.
Yeah.
And the reason for that is, and that's also what I think is so interesting with what Rebecca said initially, that today we are focusing AI a lot on improving throughput, shipping more code faster. And if we look at the studies on what developers actually do, what we see is that writing new code is a very, very small part of our day job. It's like 5% in the latest study I saw. So that's a couple of hours a week. Whereas understanding existing code, that's where we spend the majority of our day. It's like 60 to 70% of our work week trying to understand the existing system. So that's why I think readability to me is super important.
And I would like to throw in here the point, to me, a healthy code base is a code base where people can more easily work in it to make changes and evolve that code base. And so I focus on starting from that outcome end of it. And then it is appropriate then to look at things like readability, because that's contributing to that ability to change in there. And I've always believed that readability of a code base is key to being able to make changes quickly, because you need to be able to understand the code in order to change it effectively. And so I'm 100% with the idea that readability is key, but we have to remember that the driving force here is this ability to make changes rapidly and safely.
Yeah, but we haven't even talked about just correctness, right? I guess, like Adam, that's not something that can be determined by code health metrics, because the developer has to determine if it's what they actually wanted, right? And that would be checked can only be checked with tests, I guess, right?
Yeah, that's definitely true. That said, what we see in the studies we have done is that there is a pretty strong correlation between unhealthy code and defects. And I think it's no wonder. I mean, changing existing code might be one of the hardest things that humanity ever attempted, right? And if that code is overly complicated, full of accidental complexity, we're making our job so much harder. So I'm not surprised about those correlations.
It's a vicious cycle at some point, right? Like a spiral. Yeah.
Well, and it's interesting you bring up accidental complexity, because we actually did quite an interesting study several years ago. Thoughtworks, since its beginning, had been doing code submissions on a relatively small number of problems. And we analyzed it using one of the code metrics that existed at the time, which, again, much like what you're talking about with code health, it was a composite metric. It was developed by Eric Dernenberg, called toxicity. And one of the things that we noticed is that there was a barrier that if your code was simpler than this particular barrier for a particular problem, it was wrong. That you need a certain level of complexity to actually be able to get it right, which is why it's so silly when people say, well, what's the minimum level or the maximum level of blah? And you can't really answer that, because for some problems, you have to have a certain amount of complexity. And so that essential complexity really does exist, and we can't get away from it. And I think that's where, again, what Birgitta mentioned in terms of testing, we need to make sure we have a test harness that is robust enough to allow us to ensure that we have addressed the essential complexity. So let's move on to, why should a business care about code quality? As a former university professor, I still have something of an academic bent, and I would like to say that there would never be any bad code anywhere on the planet. And we all know that that's a fantasy. But how do we talk about the business value of code quality?
Well, I would bring that, this is back to that outcome point that I made earlier on. If people can make changes more rapidly in the code base, then they can implement new features more quickly. They can make changes to the software. If any problems do come up, they can fix them. All of this is much faster when you've got a high code base quality, and therefore it's better for supporting businesses, particularly as they need to change rapidly to deal with changes in market conditions.
Responsiveness, right?
Yeah.
And I very much agree with that. In fact, me and my research colleague, Dr. Marcus Borg, we published a study, I think it's a year and a half ago, called Code Red, the business impact of code quality. And what we did was that we wanted to prove that scientifically, that there is this relationship between healthy code and the ability to change and add new features and fix bugs more rapidly. And what we found was quite dramatic. It's like, on average, if you have a healthy code base, you can move more than twice as quick. And you can decrease the number of defects that you ship into production with a factor of 15. So that's quite a business impact. It means that if you have an unhealthy code base and we have a healthy one, we can implement whatever capability you have twice as quick as you can. That's the bottom line to any business.
Yeah, and I think it's really important to have studies like that, right? Because I think it's not so much about the question like, why does it matter or does it matter? Because I think most people would say, of course it matters, right? Of course code quality matters, right? But still we see people take decisions every day in software delivery context where they're trading off these types of things like readability, maintainability, all of that for other more short-term concerns, right? So I think showing how much it matters can really maybe help move that needle, right? If people really see the dimensions of what you have in your study, for example, might really help you if you think, yeah, but in this case, it doesn't matter as much, right? But if you have those numbers in the back of your mind, it might help you take more responsible decisions in the moment.
Yeah, and I could add to that in addition to that, another scenario that I personally really like with it is that having this type of data makes it possible to actually build something like a business case for refactorings and larger improvements, right? because these can now come with the business expectations that you're going to become not only quicker, but also better, and you can actually quantify and measure that. And that's something I think is important.
So you mentioned refactoring there, and this is this is something that I know you've done some studies on as well. As you mentioned earlier, Adam, it's actually a very small percentage of a developer's time that is spent on actually writing new code, and refactoring existing code is one aspect of a developer's normal workflow. Can you tell us a little bit about what you've been learning around using AI tools in support of refactoring, and what kinds of things that you've learned so far?
Yeah, sure. I'd be happy to. So basically, the challenge we were looking at was that we have a tool that is capable of identifying bad code, prioritizing it, but then, of course, you need to act on that data, right? You need to do something with the code, improve it. And this is a really hard task. So we thought that maybe generative AI can help us with that. So what we started out with was a data lake with more than 100,000 examples of poor code. We also had like a ground truth, because we had unit tests that covered all these code samples. So we kind of knew that, okay, the code does at least what the test says it does. And what we then did was that we benchmarked a bunch of AI services like OpenAI, Google, Llama from Facebook, and instructed them to refactor the code. And what we found was quite dramatic. In like 30% of the cases, the AI failed to improve the code. Its code health didn't improve. It just wrote the code in a different way. But the biggest drop-off was when it came to correctness, because in 2/3 of the cases, the AI actually broke the tests, meaning it's not a refactoring. It has actually changed the behavior. And I find it a little bit depressing that in 2/3 of the cases, the AI won't be able to refactor the code.
And what types of ways did it break the behavior?
In super subtle ways. That's the tricky thing. So we didn't make our life as easy as we could, because we choose to start out with JavaScript, which is a notoriously tricky language, right? But it could do really, really odd things, like, moving a this reference to an extracted function, which would alter its meaning. Sometimes it removed entire branches. Sometimes it chose to, negate the Boolean expression, and these things that are really, really hard for a human to track down and spot.
Like there's a little like line with a dot, like an exclamation point that is gone or in the wrong place. It's hard to see, right? And yeah, I get now what you meant about like it's trickier with JavaScript, and then you mentioned this as an example, right? And it's like notoriously like prone to bugs, right? Like in the way that that this is being used, yeah. And so, can you repeat that rate again? Like in how many % of the cases did it succeed?
So the best AI service performed correct refactorings in 37% of the cases.
37%, okay. And other in the other cases, in the other doing some quick math here, 63% of the cases, it either broke the behavior or it didn't break the behavior, but it also didn't make the health better. So you were using your health metrics to check if it was actually making the smell go away. Yeah.
Yeah, exactly. Because to me, it feels strange to say this when Martin's on the call, but to me, a refactoring, it's not a refactoring unless it improves the design of the code. Am I right, Martin?
Mostly, yes. And the reason I say mostly is it's the intention that matters. So that there are times when you'll make a refactoring that actually makes the code a little bit worse for the moment, but because of the change you're about to make, it'll make that change easier. And therefore, it's, again, refactoring is often a somewhat directed process, right? You're not just saying, oh, I want to wave a hand over the code to make it better, although sometimes you do. Sometimes you say, oh, I've got a change coming up. The code isn't in quite the right shape for that change. It's perfectly okay as it is, but not for the change I'm about to make. So I need to refactor the code so that the change I'm about to make is going to be better. Ken Beck has a lovely quote about this. It's when you're going to make a change, first make the change easy. Warning, this may be hard. then make the easy change. And I think that's the case that we have to bear in mind there. But certainly always the intention of a refactoring should be to make the code better.
Yeah, and I would say if we, we're generally talking about, can AI not only help us write new code, but can it also help us improve code or make code quality better, right? And it's also been kind of like my experience that like you can ask a coding assistant, most of the products you can ask, what's wrong with this code or what can I improve about this code? And it gives me some suggestions, and sometimes they kind of help me. But like for me as like more experienced programmer, it's often like very basic stuff like, oh, the error handling is still missing or like, so I haven't actually had impressive results yet with like, how can I improve this? And there was also like a really widely shared study recently from GitClear that was called Coding on Copilot, Data Suggests Downward Pressure on Code Quality. And what they were talking about a lot was how they had some data that they interpreted as, code bases that are partially written with AI grow faster than our code bases used to grow previously, kind of suggesting that because now it's easier to create new code than to change existing code. Maybe we just like take the easier road sometimes and just let Copilot write more code for us or a coding assistant write more code for us instead of refactoring the existing code. And I think you've also read that study, Adam, right? Like, what did you think about that one?
Yes, I read that study, and I think it's interesting because the conclusions, it's actually pretty much what I would expect from widespread mainstream AI adoption, because AI now makes it so easy to write a lot of code that shouldn't be written in the first place. So I do agree with that, but what I find in that study is that I don't really think the data would support the conclusions they make. And I think one of the main limitations is that they simply don't know which code that was AI generated and which wasn't, right? So I think we have to be a bit careful in interpreting this.
Yeah, I think it was like a blanket conclusion from just saying, oh, this is about the time when AI coding assistants became really popular, and then looking at all of these repositories and taking this conclusion. But I also agree that the hypothesis totally makes sense to me. Yeah.
And so when we think about understandability, obviously code quality is crucially important. But what are the approaches? So you all are faced with an existing code base that you don't know anything about. And now we have these great AI tools that are supposed to help us, ultimately, take away all of our jobs, which I don't believe is going to happen anytime soon. But how can these tools help in this critical aspect of software development, which is understanding an existing code base?
Yeah, so I think for the understanding a code base, I've actually seen some quite promising first features like this that, I think are not at the scale yet where it really makes it easier to navigate. But there's like a lot of combination going on of large language models with like other technology that actually understands the structure of the code, because the large language model doesn't really understand the code. It only understands the tokens, or it only knows the tokens, right? So, in GitHub Copilot, for example, you can these days also ask your workspace, your code base a question, and they're also working on combining that with like your other GitHub repositories that you're hosting on GitHub. There are a bunch of products and startups that are working on specifically helping you navigate code and understanding it and asking it questions. And I've tried a few of these tools, and sometimes it works, sometimes it doesn't. It's sometimes not the perfect answer, but it's still, even if it's not perfect, it helps me understand things quicker in spite of that, interestingly. So even if I sometimes see, this is not actually the case, it still points me in a direction and helps me navigate things faster and understand them faster. So I think there's actually a lot of potential there for the pure understanding part. But at the same time, large language models can also only be as good as the code that they're trying to explain, right? So if you have a code base full of variables that are just like X, Y, Z and ABC, then, a large language model, same as a human, will not know what the domain behind this is, right? So,
yeah, and it's also my experience. I mean, doing this benchmarking study, we have so much data that we haven't published yet. And one of the things we see as well is that these large language models, they do seem to break down pretty quickly when it comes to understanding code. So, and I think it's particularly concerning for legacy code, because one of my experience is that if you look at the code bases that would benefit the most from these techniques, they tend to have extremely long functions. I mean, functions that are 500-600 lines of code, it's not that uncommon, right? And you stuff that into a large language model and it will break down, guaranteed.
Yeah, I think especially when there's like a lot of cyclomatic complexity or deep nesting, right? I think the architecture of the large language models can't really deal with this like deep nesting. Yeah.
Yeah, I think it will improve rapidly, but we are not there yet, in my experience.
Mm-hmm.
Is there any work at trying to do this kind of stuff with these kinds of models that operate on the level of the abstract syntax tree rather than the code text itself?
We actually do a bit of both. I mean, when we did a benchmarking study, we operated at the raw text. But when we did other innovations on top of the AI, where we used other machine learning models, then we found that using the abstract syntax tree is much, much better, because in many, many cases, you can actually erase the differences between different languages. So you can have one model that understands multiple languages as long as they're in part of the same language family, same paradigm.
So, and in terms of your study, I mean, so you found this result, right? That only in, 37% of the cases, the refactorings were actually good, right? But then you kind of like went the next step, right? Like something that I see in a lot of places at the moment as well, where people are saying, okay, these results are not perfect, but like, can we put a next step behind the suggestions that we get from these tools and kind of assess our confidence in this, right? And maybe not even show the results to the human, that we can automatically determine that we have very low confidence that they're actually correct, right? And you all also did that, right? You went the next step and tried to kind of filter out the ones that you could determine with automatically that, they're probably not correct, right?
Yeah, that's right. Because at first, I mean, 37% correctness, it's pretty depressing, right? But when we looked closer at the data, we saw a couple of interesting patterns. So we saw that the different AI services, they seem to be good at different things. So we kind of try to use that to our advantage. So instead of going directly to, let's say, OpenAI or Google, what we do is we go to something we call a model selector, which is basically a pretty simple machine learning algorithm that has been trained to understand that this type of code, pick OpenAI. This other type of problem, pick the Google AI. So already that kind of improved the success rate. But then we also made sure to add some fact checking on top of the AI response, right? So we fact check it to make sure it improves the code health, that it doesn't do anything strange, like removing entire branches that we don't expect to be removed. And if we find that any of these fact-checking tests fail, then we throw away the result and ask another AI for a new one. And once we get something that passes our checks, we can safely pass it on to a user that can inspect the code and apply it if necessary.
Did you find that there were patterns and instances of where you didn't ever get something that you found acceptable?
We never published that, but there were definitely some patterns that the AI seemed to be really challenged with. And it's usually about things that you don't really want to do as a human programmer anyway, but so many code bases are full of it, like continuous statements inside deep loops. The AI really struggle with that, for example.
And something I learned from reading your paper is that, so when you were doing this, you had to kind of determine, does this change the behavior? Yes or no, right? Does the behavior change based on the compared to the previous state of the code? And I learned from your paper that that's actually not a solved problem. Yes. So you had to kind of like go back to your data lake and use, your all of your previous experience with analyzing code bases to make this possible, right?
Yeah, that's right. That's right. So so when we make this claim that we can guarantee that the code is semantically equivalent, it sounds like we have solved the halting problem, which would have been cool, but we didn't. But yes, we had a benefit of lots and lots of data with the known ground truth. Is their refactoring correct or not? And that helps a ton, of course, in building these algorithms. But it's also the case that we could constrain the problem. Instead of doing like a general semantic equivalence check of all types of code, we could constrain it to these specific refactorings, and we could even constrain it even deeper because we knew that this is a specific code smell that we have instructed AI to refactor in a certain way. So that makes it much, much easier to fact check the output.
Okay, so also the context in the CodeScene tool that it had, like what code smell it is about and so on, you use all of that information to do your confidence assessment, yeah?
Yeah, that's correct.
Shades of my work with compiler optimization so many years ago. And so based on all of what you have seen, what would you recommend for developers getting into using these coding assistants in terms of mitigating the risk of generating bad code or using refactorings that are subtly wrong? Is there any guidance for people who are starting to use these tools on how they can use your work to mitigate against the risks that you've uncovered?
So I do think that traditional tools like linters are super useful together with AI tools. I also think it's obviously important as well to keep an eye on the code quality. So I do recommend having something that can give you feedback on code quality very early on as you write the code. And then the last thing I want to point out, and I think this is more of a concern for the team, but that is the whole code familiarity aspect, because the quicker we're able to generate new code, the harder it is for the team to understand that code. And I have found as well in the studies we have done that unfamiliar code, no matter how healthy it is, it's still going to be a challenge for you. It's going to be a barrier to entry.
Yeah, and a lot of people are asking this question these days, like, oh, how do I know if, using a coding assistant or using any Gen AI for any of my tasks in software delivery, how do I know that it's actually worth it? How do I measure this, right? For me, it's like, it's still the same way that we measured the outcomes before. We just have new tools now, right? But there is like a perspective on this that when you're using AI for this, then especially like monitoring the risk, there's like certain things that we can maybe now specifically monitor that maybe before we didn't even look at as much, right? Like not only our like common code quality metrics, but based on this study or this like hypothesis, maybe I want to look at like the growth rate of my code base, right? Like maybe I've already like maintained it for a year or two and I have historical data about like the growth rate before. And, now maybe I look at it and of course, putting into context, like how many features are we working on these days? What are we actually doing? It always has to be put into context, but maybe I can actually look at this growth metric, right? Or I can look at like, is the size of my change sets to production actually getting a lot bigger because like, whenever the commits are getting bigger because I'm writing more code every time I use Copilot, right?
Maybe even things like copy-paste detection, keeping track of some of those. That's in at least one of the studies that I read, that they found that there was more copy-pasting going on as a result of, or not necessarily as a result, but there was a correlation, not necessarily causation, with the use of the coding assistant and an increase in copy-paste.
And then also what you said, Adam, about the familiarity, that's, I think, again, like maybe like a qualitative survey, not something that one can measure with a tool. but like really asking developers, do you feel like your debugging time is going up, right? Like when you have like an incident and nobody really understands the code. So again, these kind of like more qualitative surveys about developer and debugging experience and stuff like that.
Well, and then of course there is the perennial issue of what does developer productivity mean anyway? But we won't go off on that tangent at the moment, I don't think. So I do have one other question. So again, you know, Birgitta and Adam, you've both spent a lot of time with this. As we use these tools more, as more of our code bases have been touched by these tools, do you see fundamental changes in what it means to be a software developer? Are we going to worry more about different kinds of things than we did before? You know, can you talk a little bit about what you think things are going to look like with respect to these coding assistants? You know, obviously the models, well, not obviously, but likely the models will continue to improve. But what about the whole day in the life of a developer? How might that, how do you think that might evolve?
I think that AI coding is less overhyped today than it was maybe a year ago. A year ago, we still heard about like the end of programming and all of that. And I don't think anyone realistically believes that today. However, it's very clear that we're only seeing the beginning of this trend. And yes, the models are going to improve. The tooling is going to improve. And I think that we're entering a challenging phase because over the next decades, we will have this hybrid model where humans need to understand code that's developed by an AI. And I think it's really, really challenging. So what I think that means is that as organizations that build products that develop software, I think it's going to mean that we need to re-emphasize the importance of all these basic engineering principles, like good test automation, healthy code, right? Maybe we even see a renaissance in the importance of code reviews as a way of maintaining familiarity. So I think a lot of these old techniques are going to become even more important today in an AI-assisted world.
Yeah, I like what you said about the hybrid mode. Like, at least if I understand you correctly, it's kind of this, like, as long as we still need multiple humans collaborating on code and we don't have that one AI that does everything, as long as we're not like 100% or almost 100% there, like still a lot of the things that we're doing today about collaboration and reading code and all of that will matter to some extent, right? So, yeah, I agree with that. And I also think it's here to stay and it will get better. And so even though there are a lot of risks and flaws and things that don't work, maybe some of them don't work yet, some of them will never work. Yeah, it's just like for us as a profession now to figure out how to use this responsibly, right? Like, and for me, like my favorite example is test-driven development, right? Like I still think it's relevant, but maybe it will change in the shape that we're doing it, right? Because a coding assistant generating tests is just too tempting for people to not do it. But if you then generate your tests and your code and you don't even check if your tests are effective, you know, then you're like going down a really slippery slope, right? So how does TDD change? So we still get the benefits, but we also maybe use an AI to help us write those tests faster, maybe for the edge cases, right? So that would be an example where maybe one of the practices I think that is most immediately affected, like even today and not only in like a year or two or longer.
So Martin, you've clearly thought a lot about TDD. What are your views on how you think this is going to impact a practice that has been so central to XP?
Well, I'm, again, interested not so much in the AI tools generating code as the AI tools telling me things about the code base, particularly with a code base that I need to know. So on the TDD prospect, I'm immediately interested in, are there areas of the code base that aren't very well covered by tests? What are the kinds of changes that could go? Again, it's like the mutation testing problem. Are there parts of the code base that we could introduce a bug without the tests detecting that a bug has been introduced? So I would like to find that kind of thing out for me. It might also look at areas where I might have tests that are overly detailed in the internal implementations and say, can they be replaced with tests that are less dependent on that, particularly if it's an area where I'm looking at changing some of those internal cases. And that kind of thing is interesting to me.
Overlaps in tests, right? Like where are things that I'm like testing over and over again on each level of the pyramid?
Yeah. Or even in less obvious cases where it's even the same place, but just because I wrote tests in different cases in different parts of the system. I'm interested in AIs that will just tell me things about, hey, I need to change this particular kind of output somewhere. Where's the code that figures all this out? Where is this being touched through the code base? Even simple things of, where I'm hitting this database table. Tell me all the bits of the code that contribute to hitting this database table or not. I mean, a lot of this we can do with searches, but I suspect with an intelligent tool that's kind of I don't want to say trained on the code base, but has ingested the code base, hopefully would be able to answer much more interesting questions than I can currently do by throwing regexes at the code base at the moment.
And I think finally, it's also worth pointing out that all of these things that you just mentioned, we don't necessarily have to only turn to generative AI just because it's the hype of the moment to do this, right? And Adam, I think at CodeScene, you've used you've used machine learning before all of this happened to suggest refactorings and all of that, right? So do you also see like a resurgence now in interest of using AI to improve code health, like even beyond large language models?
I do, and in particular, what I see is on importance in data, in having not only enough data but the right type of data, because all these algorithms are extremely data hungry.
Yeah, and in this case, the code is the data, of course, right?
Yeah.
Well, I'd like to thank you all, Adam, Birgitta, and Martin, for joining me today with this discussion of AI refactoring and code health, code quality, and how our lives as developers might be changing, and all of the both exciting potential and very real risks that we will be facing. So thank you, Adam. Thank you, Birgitta. And thank you, Martin.
Yeah, thanks. And I got a bunch of new ideas of what I will try to ask my coding assistant tomorrow.
Excellent.